So the panel discussion is something we've done every year of the conference, in fact. And it's a kind of a good way to make things a bit more informal, wake people up at the end of the day, and get some kind of less structured opinions on server-side Swift and Swift itself. So to start with, we'll do kind of just introductions, a couple of sentences about yourself. For those, well, some of you should know them because they've spoken, but the rest of them might be new. So I'm Tim. I'm the organizer of the conference. I maintain Vapor. I'm one half of the core team of Vapor. So I spend a lot of my time working on open source.
So I'm Simon. I'm at Prime Video. I did a talk before, if you remember.
I'm Ellen. I also did a talk before. I do iOS at Gusto, the one that doesn't send you moldy food.
I'm Adam Fowler. I'm an open source developer. Work on Soto, the unofficial AWS SDK, and the Visual Studio Code Swift extension.
I'm Jimmy McDermott. I serve as CTO of a company called Transio. We build educational technology, and also serve as a member of the Apple server-side working group.
Oh, yeah.
Adam, too.
Oh, and me, yeah.
I'm Ted Krumnick. I'm the director at Apple's Languages and Runtimes group, which has basically all our programming language work, Swift, C++, Objective-C, and I am a member of the Swift core team.
Cool, great. So everyone on the panel has kind of been picked because they either have experience building SDKs, experience building kind of big open source projects, experience working on Swift itself, or building kind of production systems using Swift on the server. So I've got some questions that we're going to kind of run through over the next half an hour-ish as we kind of wrap the discussion up. Some of them are more direct to the people, some of them are more kind of open-ended. So to start with, we're kind of going to have a few open-ended questions that everyone can kind of chime in on. And so the first one is, what are you most excited about that's coming up in Swift in general? Not necessarily just about server-side Swift.
Yeah, so I think for that, we're sort of getting to the next level, I think, of Swift as a language. So the stuff, hopefully, with registries, I think will give us a platform where we're sort of leveling up the language, and the language is going to be, I think, compared to other languages, much more comparable and can compete much more.
Yeah, I think I'm also excited for package registries, mostly so I don't have to pull the entire Git history of everything that I need to check out. I think that's going to be a huge help. And I think I'm excited for some of the memory safety stuff that's coming. I think I've had an accidental joke a couple of times that that's something that we should borrow from Rust. But
I'm still trying to catch up on what happened over the last year. So like I've been looking at like build plugins as you were talking about, and the command plugins, and I think what we can do with that in the future, in the next year or so, should be really exciting.
Yeah. I'm really excited about custom executors and whatever form that eventually takes. Hopefully it takes a form eventually. And then I also really like the foundation work that was announced today. Very excited about that, and see a lot of use cases coming out for that. So
there's like so many things to be excited about. So a few weeks ago, I think the Swift blog had here's like a bunch of focus areas for 2023. And if you haven't seen it yet, it's like just really awesome to see all the stuff. One of the things I'm particularly excited about is some of the community restructuring that we did that's going to tap a lot more into the community energy with like more work groups and so forth. Like I think the server work group is like an excellent example of like how effective that's been. And there's just all this potential in the community to push Swift a lot forward. On the technical side, there's like obviously the concurrency work and moving towards data erase safety by default in Swift 6. If you haven't been following along, C++ interoperability is coming along really well, and that's going to open up a whole bunch of doors with new use cases for Swift. And the foundation work, right, is super exciting. So, and the memory ownership, I mean, that's going to open up lots of places where like doing fine-grained performance tuning and modeling things like non-copyable types without having to worry about like shared state across threads. It's just going to help next level a whole lot of use cases. So it's all that stuff is just really exciting when it all comes together.
Yeah, there is a lot of stuff kind of converging, I guess, for Swift 6. I think from my point of view, certainly, Swift 6 is going to be a good kind of stake in the ground for Vapor. So the kind of plan for Vapor 5 is to release that alongside Swift 6 whenever that comes at some point in the future. Because we know at that point there are going to be some breaking changes that they can introduce, and we're kind of going to use that as an excuse to break Vapor's API. We're now at the stage in Vapor where we can't really just evolve quickly and break things because we have too many large open source and enterprise projects and applications using it, and we kind of have to kind of acknowledge that. It's not like the early days where we can just release a new major version and it's fine because the enthusiasts will update. We now actually have people using this in production with like huge systems, so it's something we have to be aware of. So we're kind of planning that from a long way out. And I think, we're kind of really looking forward to adopting Swift concurrency throughout the whole stack rather than just kind of wrapping the old event loops future stuff and pretending it's all nice and new. Using Swift Sendable to kind of make all of the data race stuff a lot safer and shifting all of those kind of errors through to the compile time rather than runtime. So I think it's going to be a really interesting time when that kind of starts to come out. So following on for that question, is more about what are you excited about that's coming up in Swift specifically for the server, and kind of what stuff that you'll enjoy and look for.
Yeah, so I think for that, I think structured concurrency actually. So to what Corey had his talk on about, it's I think going to be a new paradigm for how we write services. So around structured concurrency and async sequences and being able to do things like standardized middleware and distributed tracing, I think there's going to be a lot of power, and we're going to be writing much more powerful and flexible services, once we get that done.
Yeah, there's a lot of stuff coming in from the work group and the kind of community around the middleware. So something we've been discussing about creating a kind of generic middleware type that Smoke and Vapor and Hummingbird and any kind of stuff built on top of Swift Neo can use and build on. And it allows us to offer, say, a metrics middleware that we can all use and take advantage of, or a tracing middleware. So that's exciting, yeah.
Cool. I think for me, distributed actors seems like it's going to be a really interesting thing. I think I'm really interested to see sort of both how that can be used within single applications, but also how it can be used between an iOS app and a server-side app.
Yeah, distributed actors are a very interesting, powerful tool that I think a lot of people still are a bit unsure on kind of how impressive a piece of technology it really is. And even for like the server-side world, because it's realistically it's a server-side thing, isn't it? Like iOS apps are great, but Swift on the server is where it's at. So like I think seeing that kind of grow into fruition and the ways we can use that is going to be really interesting.
I was going to say the distributed actors as well. My past is in gaming, and we worked on a network game, which was a peer-to-peer network game. And when the distributed actor system came out, it was just like, that's what we needed then. It was in C++ though, so that was. I guess the other things are there's just a general bringing together of systems so that they all work in together, like simple things like the logging and the tracing. They're all starting to come together so that you get them. It's a lot easier to just, if you've got logging, you get tracing, and you can just, it's almost a flick of a switch almost. That would make life a lot easier for everyone. I'm trying to think. That's the two I was going to think of mainly.
Yeah, I think so. The like low-level packages like Swift Log and Swift Metrics and Swift Tracing, they've been really kind of fundamental in bringing the ecosystem together.
Yeah.
And the kind of the state that we would be in now is it would be completely different if Vapor had its own metrics implementation and its own tracing and its own logging system, and then Smoke had its own versions, and then things like Soto or kind of any other package had to then re-implement it. So for those of you who don't know, there's some kind of low-level packages in the server ecosystem, like Swift Logs, Swift Tracing, Swift Metrics, that allow us to, like, as framework developers and application developers, to call logging functions or metrics functions, and it doesn't matter where your logs end up or where your metrics, kind of what metrics backend you can use. You can just kind of bootstrap Prometheus or bootstrap CloudWatch, or and it will just send the metrics there. So
I've been very impressed with how much care has been put into those packages as well. They're really simple, a lot of them. They don't do a huge amount, but to get them right, and to get them right for everyone, is really hard work. And there's been a lot of iteration over and over and over to get it right, and so that's been very impressive.
that they are the foundations holding up a lot of the servers,
Yeah.
so they have to work. Yeah.
Yeah.
I think one of the things I'm really excited about is baggage with distributed tracing being passed async around the app. We do a lot of things right now where we try to arm wrench logging into doing what tracing is really supposed to do, and it's just not very fun, and so I'm looking forward to that. And then the other thing is binary and image size, and I know some of the foundation work will help with that, and then the stuff with Canonical and Ubuntu was really interesting on that front, because our image sizes are bloated right now, so looking forward to solving that however we can.
Yeah, so I worked on a project last year, that actually implemented tracing in Vapor using distributed tracing before it was kind of tagged as, before it's been tagged as 1.0. And we had to take the approach that most other languages take, where you have to manually pass the context everywhere you want tracing, which meant kind of, if you want to make a call, you have to pass context to context. And it's like the, I don't want to say issues with event loop futures, but it's kind of like that nested hell of it just ripples everywhere.
Yep.
So having that kind of automatically done using task local values is going to be cool.
Definitely, yeah.
I just echoing some of what was already said, like feeling that wavefront of concurrency that could go through like the server ecosystem. I think that's gonna be really awesome. Some recent work that's like showing up on the forums, the cross compilation work. I think that would be really great for streamlining like some server development workflows. And the foundation with like that unified implementation, you know, with Linux and Apple platforms and Windows, that's just going to be really great. So
I have
really
tons
excited
of
about
GitHub
that.
issues to close. That's what I've been my bugbear for the last few years, I think. Cool. So like moving on from what we're really looking forward to is kind of what do you think is missing in terms of what does Swift need to continue to grow and become a real, well, I don't say real, but like a kind of more accepted Swift, more accepted server languages?
I think stuff around deployment. So we saw some talks talk about deployment, and I think that's good. But I think being able to easily deploy to different cloud providers and different deployment mechanisms, I think, is going to be important to be able to have more developers use Swift without having to know deeply how to deploy services.
Yeah, I think that would definitely be good, because I absolutely have no idea what I'm doing. But I think one thing that I find really interesting is bringing Swift to hardware that is non-Mac, mostly because it's quite a bit cheaper, and there's definitely some equity issues in terms of people who are able to learn Swift. If they're learning it for iOS development, they have to be learning it on a Mac. And I think if they're learning it for server development, then you see some options in terms of Linux and potentially Windows in the future. And I think that's really something that I feel like pushing some of that even more on an education level could be really, really interesting and get a much wider group of people into Swift.
I think we should, at that point, call out the work that Adam's been doing on the VS Code extension that has made.
Yeah.
That definitely deserves a round of applause, yeah. Because if you haven't used the VS Code extension, even on macOS, it provides almost exactly the same experience as using Xcode. You get the same features, you get debugging, you get breakpoints, and it just works. There's no setup required. There's no kind of configuration files. It generates that all for you, and testing works. And it's a really nice experience. And it means you can, if you're on Linux or even Windows, you can kind of just install the plugin, and get started. And it's really made a big difference to a lot of people's workflows, I'd say.
Well, that's kind of where I see we need to improve, is that cross-platform experience. Obviously, we are in a better place now than we were like 12 months back. But have you tried to install Swift on Windows and use it?
I don't know in Windows, so
the majority of students, when they go to college with a Windows laptop. If you want them to learn Swift, it has to be easy to install, and it has to have proper support. At the moment, we have maybe a couple of individuals at the moment who are putting in a lot of time, and we need to improve that.
yeah, cool.
Yeah. I think one thing that is really important for the broader ecosystem, that will become even more important once all these things start to get solved, is we need more companies putting more money behind server-side Swift and doing more visible events, to make it clear that, again, it's like a quote-unquote real language. Obviously it is, right? But events like this are awesome, and this is a perfect example of that, and we need more companies out there talking about their ability to use it and how they're using it and their successes with it and their challenges with it, and attract developers to the ecosystem.
I mean, the community has done a really great job of building like all these like libraries and tools. But there's still a huge opportunity there to go deeper and wider, with supporting like the broader ecosystem. So I think that's a huge opportunity for the entire community, to build out more there. I think the VS Code work, for example, has been fantastic because it just like has opened up, all these, additional access to Swift for a wider range of developers, and seeing like more of that kind of stuff, so you could reach even more people.
Cool. I have to definitely echo with what Jimmy said in terms of like, we know, certainly from Vapor's point of view, we know that there are lots and lots of companies using it at a massive scale, and it's just kind of building those success stories, making them kind of more accessible. I know, Simon, you've been talking on Twitter about how you've been using Swift on the server, and that's kind of a really good example of, if it works for Prime Video, there's very few people that are going to have bigger scale than that. So like, it's kind of like, if it works for you, it's going to work for everyone. And then I think, from my point of view, like things that could be improved and are missing are some of the like tooling stuff, which is like my other bugbear other than Foundation, in terms of like, there's lots of things in the server world that other languages have automatically. So things like Dependabot on GitHub, which will scan your dependencies and show if you have any dependencies either out of date or have got security vulnerabilities, and automatically suggest updates. Those kind of things that Swift needs to be able to kind of be accepted in the enterprise world. More security advisory databases, which we've kind of started working on and kicking off. And yeah, general tooling. I don't know if, Adam, if you want to briefly mention Swiftly as kind of a...
Oh yeah, that's obviously making it easier to install on Linux and hopefully on Mac OS and Windows. This is at the moment, when you want to install on Linux, you have to download a tarball, you have to unzip it, stick it in a folder, and then set up your path, and it's a pain in the butt, and you can get it wrong, and then you want to get a new one, and so we are in the process of developing a small tool for downloading these automatically. It'd be similar to, I forgot what it's called.
Rust Up.
Yeah.
Yeah, Rust Up. So you just basically go swiftly install 5.7, and then you get Swift 5.7 or 5.6 or whatever. Yeah.
So I think that's going to be, well, Most of the work's done now, isn't it? And that'll be-
There's a chunk of there's still stuff to do, but like there should be. I think there will be a live GitHub repo soon that should be visible to most people.
and people can start trying it out and using it and
Yeah.
kind of providing feedback. So I think that's a really important thing, because if you go to the Rust website at the moment, the first thing you see is install Rust, and there's a command you run, and you type that command in terminal, and it installs Rust for you, and then you can just do Rust build or whatever. And having something similar for Swift is, I think, where you don't need to pull down all of the. If you're building server applications, you don't need to pull down the whole iOS SDK, for instance. That would make it really, really powerful.
And it's also written in Swift.
And it's written in Swift, so
So if anyone wants to help,
when the repo's live, I'm sure we'll there'll be forum posts and maybe a blog post about that as well. Cool. Okay. So next question is mainly for Jimmy and Simon, but for everyone to kind of chime in, is what advantages does Swift have over more traditional server languages? And in terms of why would you pick Swift if you're starting a server application or server services these days? I know you kind of touched on it at the end of your talk, but why would you choose Swift over, say, legacy languages like PHP and Python, etc., and kind of the more modern languages like Go and Rust?
So PHP is actually banned at Amazon, so we can't actually use that. So, I would not advise using PHP. I think, as we've touched on, the safety that Swift provides in terms of type safety, compile time guarantees, I think is very important for developer productivity. So, generally, if you can compile it, the compile time guarantees it gives you means that as long as you haven't made logical errors in your application should run without configuration errors at runtime. I think the other main advantage, and we've definitely seen this in the metrics of our services, is that the memory footprint of Swift is just insanely low. We are nowhere near having memory constraint issues with our services, because it's just couples of percentages of the memory that we're using on hosts. So if you're specifically using or needing services that have large memory requirements, then Swift obviously has a lot of benefits there.
I've actually got an open issue on the AWS container GitHub org to ask for Fargate tasks with smaller amounts of memory, because Swift services take so little memory that you end up just having, you can use loads of CPU, and then just like like you say, your memory is like 1 or 2%. It's like, well, this is a waste of money for us.
Yeah, and actually on that note, we last I checked, I think we're over allocated on memory by about 500 gigabytes because we needed the cores, and you can only get machines that. So it's kind of painful to look at. But yeah, I would agree with that. So beyond that, in terms of using it and the benefits there, I think one of the main things that we've seen as it relates to the speed is the number of servers that we need to run our workloads is so dramatically lower than what we would need under other workloads. And we're a startup, and so every dollar and every penny counts. And so that's actually been like a meaningful, looking back at the past 2 years, has been actually a meaningful line item kind of on our profit and loss, that we've actually saved meaningful money with that. So I think that's amazing. And then, yeah, it's really great. And it's really a testament, again, to the memory stuff and just the efficiency of it. And so there's that. And then the other side of it is that, similar to other strongly typed languages, but certainly in Swift too, it just eliminates an entire class of bugs for developers, and specifically for new developers that are on-ramping to the team. They just literally cannot make mistakes that you could make in other languages. And so that just eliminates an entire class of needing to train them around certain elements, and even like removing documentation. We don't even have to document certain parts because it just works and you can't break it. And so I think that's huge also from developer productivity, and certainly, when you keep, as like a team leader, when you keep your developers happy, that's a good thing. So,
Anything to add,
the only thing I can think of on top of what these guys have already mentioned is probably the error handling. obviously I've spent quite a bit of time with TypeScript over the last year, and error handling in TypeScript is interesting. You don't know if a function throws an error. It might not. You call it, and then eventually, sometime later down the road, it throws an error, and you weren't warned. It's just another safety feature. We have to put try in front of everything that throws, so that we know it throws an error, and that's a good feature.
And it won't compile without.
Yeah.
I mean, just like at a higher altitude, I mean, I think the services space, I think, is hungry for a language that strikes a balance of like safety, performance, and like ergonomics. And you have like Java, great on safety, but like hits limitations with the garbage collector, from the performance front. Go has a lot of adoption, but also inherently has the same kind of performance limitations because the garbage collector. And then like languages like Python and Ruby and so forth, they're easier to use, right? But they're a little weak on the static type safety and weak on performance. Rust is really interesting because it's, trying to dial into that safety and performance, but then it compromises, with the ergonomics because it's such an onerous model to buy in for a general programmer. You have to like buy all into the model. Once you do, you get a lot of benefit, but it's a high bar to jump. And Swift, I think, just kind of hits all of those points, simultaneously, which I think is really its like value proposition, that it brings to the space of, performance, safety, and it's easy to read and write.
Yeah, definitely. I think one of the focuses for the Swift.org website, which is now open source, so I also sit on the Swift's website work group, and we're kind of looking at expanding sorry, there's a few other people in the audience as well, Dave and Rita as well. And one of the things we're kind of focusing on is improving the kind of, I guess, the landing page of Swift.org and like showcasing Swift is a fantastic language. It's deterministic, which puts it above anything that's garbage collected. It's simple. And I see a lot of things on Twitter. I've got and when I do talks on Swift at conferences, I've got like lots of examples of tweets have been like, oh, we need something like modern like Rust and Go, but Go's too simple and Rust's too hard. If only there was something in the middle. Yes, it's Swift. So it is a really good example of stuff to use. Okay, so looking back on the last year, or rather 2 or 3 because of the C word, what has been your highlight for either Swift in general or Swift on the server?
So I think structured concurrency again, and specifically being able to refactor our code and simplify our code as we refactor it, I think has been quite a joy. The code that we have produced is much cleaner and much easier to understand than what we had before. And so I think that is a big boon.
I have to agree with that. And I think I have to call out both the Swift Neo team and the Swift compiler team for making it possible to kind of incrementally adopt concurrency in their applications and moving from futures or value futures to async await rather than having to do it in one massive go. Because it means that Vapor 4 can support old code that hasn't been updated and allow people to do new stuff without having to go, right, we're breaking here. If you want to use the new fun stuff, you have to rewrite everything.
Yeah. I think the thing that I was most excited about was the backport of Swift concurrency to iOS 13. I've done a lot of work on both iOS and Android, and one of the things that Android sort of by nature of how Android is manufactured and distributed has had to do is figure out how to have these backfills that say, hey, if you're using this on an older operating system, here's a way that it gracefully degrades. And to see that coming for a developer experience standpoint for iOS is excellent because it's really something that saves you a ton of time. It also gives you way more options to adopt these new APIs. There's sometimes some jokes about people saying like, I'm going to WWDC to learn what I'll be using in 2 years, and being able to say no, you can actually use this right now, even if you're not supporting the latest and greatest right out of the box. That's fantastic, and I would really, really love to see more of that.
I think we in Vapor get a non-zero amount of requests per month asking us to enable backporting of concurrency to iOS, older iOS versions. Surprisingly, there are people using Vapor on iOS for either running local servers or mock servers or stuff, and at some point we will enable that when we drop 5.5, I think. So,
Cool.
Can I say Swift concurrency as well? I think, well, outside of Swift concurrency, I think it's just over the last 2 years, everything seems to have solidified a bit more. Everything just seems to work better together. It felt like when I kind of came into the sort of community, the ecosystem was a bit fragmented, and everything just seems to work better together. And you start up a Vapor server, and you get the Redis stack, and you've got Soto, and then you could also start up a Hummingbird server, and you've still got all this stuff. It's still available because it's a decision which probably I think it's Tanner maybe made. I'm not sure. Maybe Johannes, where all the systems were being built without a Vapor requirement.
yeah. So so a lot of Vapors. So Vapor has like 60 odd packages in its organization, and half of those are things that we call package kits. So it's like Postgres kit or Fluent kit, and they're ORMs or database drivers or JWT libraries that have no dependency on Vapor.
Yeah.
So you can use them in any kind of ecosystem or in any world. And then we have a very thin compatibility layer that kind of maps the two together.
Yeah. And that's really helped, I think, as well, because it means you can use it with other systems as well.
Yeah, and it's been really cool to see as well some of the other frameworks, or even like newer frameworks, picking up and using either like Vapor's router or things to kind of build new ways of doing things. I think it just helps grow the ecosystem.
Yeah.
Yeah. I think over the last year or two, what I've been excited about is that I can sleep at night without worrying about my services, and that's because our DevOps team is me, team of one, and so actually, funny enough, recently we had this like huge, a bunch of our school districts launched at once. We had this huge influx of traffic, and so we were all the developers were kind of crowding around the metrics, waiting to see what was going to happen, and the back end like didn't even really register a blip, but the front end failed, which was kind of funny. React kind of gave out. So that's been nice, not having to worry. And we ported a bunch of stuff over to Swift over the last 2 years that used to be microservices and Python and PHP actually, which we ditched as well. And so yeah, that's been very nice to just not have to worry.
I mean, there's like so many things. I mean, I think with the concurrency work, I think distributed actors is kind of like this like hidden superpower there. And we look in like the services space. I mean, now we have like the capabilities to build like these large scale distributed systems, combined with like frameworks like, Smoke and Hummingbird and Vapor that can power like these traditional web services. There's just this real force multiplier there now with like the kind of things that you can do. And I think just another really big highlight is the VS Code, support. I mean, I think that's huge. It's like reaching where there's lots of tools that people are using, and Swift needs to get to the places where in the development environments that those people are used to using, and matches with their flows and so forth. And so it's just really great to see. And again, it'll be fantastic to see more of that.
Yeah.
Awesome. I think for me, highlights of the last year or three. Yeah, it's very hard. Like Swift concurrency is obviously the big standout that's made code so much easier to read and maintain. I think it's hard to understate how significant a change it is reading code using async await compared to futures. How much less kind of jumping around and twisting yourself into weird shapes you have to do to try and make very simple stuff in kind of a synchronous world work with futures. So yeah, I think probably I'll echo everyone else's, is that concurrency is obviously the standout feature there. Okay, so I think we've got kind of time for one more question and then we'll wrap up. And it's more just kind of throw out there if anyone wants. It's kind of how has Swift helped you with your server applications or your applications or SDKs in terms of what benefits it's brought you?
I think I'll probably go back to something that we talked about before, which was about developer happiness, which I think on our team is actually pretty high, and I think that does come down to Swift. I think the developers like this language, and I think that helps the team, it helps morale, and it helps productivity on the team. So I think in general, Swift has been very positive for us, and that I think the ergonomics of the language have played a big part in that. And so I think that's down to everyone in the community who has written code, and Apple for developing and shepherding the language as well.
Yeah. I would just add to that too, and I think what we're discovering, and we saw it in a few talks today, and certainly in yours, Simon, Swift is proving to be a really good language on the server side for compute-powered resources. Specifically, I know for us, for example, we ingest a ton of nightly CSV files from our clients. Certainly not at the Amazon scale, but it certainly it seems to be a really good for those workloads. So I think that's kind of an exciting future for the language as well.
Cool. I'll talk a little bit about my previous job. I used to work at Apollo GraphQL, and one of the things that was really exciting about being able to combine Swift and GraphQL was the ability to really create this end-to-end type-safe environment where you could have this schema definition, and you could use it to generate Swift code that you essentially you could compile, and you could know whether your request was going to fail or not. And that was just sort of magical to be able to do that for all of our clients, because it just eliminates entire classes of bugs that you have to deal with when you're a client developer working with the server. And so it's something where I think one of the things that I'm really excited about is how we can integrate Swift with other technologies to make things even better.
I think I'm going with joy as well. The joy of developing in Swift. It's just a lovely language to work in. I spent 20 years working with C++, so possibly anything would be better.
I think it's a lovely language.
Cool, awesome. Yeah. I think for me, it's the safety. Is that if it compiles and the tests pass, you can basically just deploy it on a Friday evening just before you go home, and don't really have to worry about it.
Still don't want to go that far.
No, please don't.
But yeah, it's if it compiles and it passes CI, you don't really have to worry too much about it. There's no anxiety around deploying it. Sure, things go wrong sometimes, and you make a mistake in migration or whatever. But for the most part, it's generally just a bit. It's relaxing. I think that's the main thing. Coming from, my background is very varied, and I've done lots of languages, but coming from kind of interpreted languages where you don't know if you've got an error in your code until you ship it to production, is having a compiler is has a real godsend, I'd say. Okay, cool. If you'd like to put your hands together and thank the panel for taking part.